welcome you all for the inauguration of MTTS chapter, which is Microwave Theory and Technique Society chapter. We have got the approval of this chapter in the at the end of the last year, and today we are officially inaugurating this chapter for all. So as a part of this inauguration, we are conducting a panel discussion on the topic of the 5G technology, which is very vibrant right now. We can hear about the 5G technology from all the perspectives. So I request Padmasai ma'am to address the gathering and welcome all the delegates to the session.
So thank you, Priyanka. Respected dignitaries present here and my dear colleagues and student members. So warm welcome to all of you for the panel discussion on here, clearing the air on 5G interference and aviation safety, and so warm welcome to 5G implementation. In association with IEEE Hyderabad section MTT chapter, VNR SPS, Hyderabad section SPS and WIAG, we are organizing this event together. So safety needs to be value, not a priority. According to the code already we have circulated. So we should take care of this thing. Recently we have seen the impact of 5G, how the flights are about to clash. But fortunately nothing happened. So this event is because of our president, former president Dr. Nano sir. As soon as that accident everyone is saved. So sir mentioned the importance of communications and instrumentation that should be known to all of us. Even though some of the members are not belongs to communication background, but as a citizen of the country, we should be aware of how technology is changing and what are the precautions we have to develop when any product is developed. That is very much important. Now everyone is talking about mezzanine technologies, that is AI, ML. Those technologies are used in our communications. What are the precautions we have to take care? So I request all the students, so please aware of things, not only reading from your book, you have to attend as many number of events as a student, so that you should contribute to the society which is useful to our nation. We have seen during pandemic how we have suffered. So because of many things we are importing, even small sensors also. Now government of India came forward to start all those things in India. You are having a lot of future for that. Instead of all the time going for software as an electronics engineer, you should start your own startup. College is ready to support you. Already we are having seed money of 5 lakhs. Whoever is doing any incubation activities at our college, you can use that 5 lakh grant as initial seed money, and you can establish your own startup. You can experiment as a student. Even though sometimes you may fail, nothing will happen. All our innovation, you see, any innovation without one goal, it is not possible to success. Okay, we have to experiment many times. Okay, all innovations, after you take any innovation, after failing, they have raised many times. According to Newton's third law, all of you studied. Okay, you have to bounce back 100 times so that you will become successful engineer in your life. So I welcome Dr. Nano sir, Mr. Sandeep for supporting us to initiate MTT chapter at our college. All your support, we are able to start this at our college. The need is very, very important, communication chapter. And I thank Mr. Nishant and Mr. Subhash sir for supporting whenever we are organizing any communication event at the college. Your support is always there, sir. Thank you. I welcome all my colleagues. Back of this, Archana ma'am, Kanti Sudha, Kalyan and Priyanka. And I thank you and welcome to this session. So I request Nano sir, please share your views only for some time only. I welcome Nano sir.
Thank you very much, Padmasai, and all the guests. and all the members of VNRVJIET. I'm so happy that you are conducting this seminar. One thing, Professor Padmasai, if I can comment, probably I will start with not so much of a positive note, but your tagline. Can you please repeat your tagline, yesterday's invitation? Your tagline for this seminar?
Safety needs to be value, not priority.
I think we have to get it examined, Amma, that as far as industrial design and equipment design and product design is concerned, nothing supersedes safety. Safety everywhere. I think nothing supersedes safety. And so I think we will modulate this meeting probably with that modulation, that safety is also safety is the topmost priority. Okay. With that comment, I think I request the guest to go ahead with the conversation, please.
Thank you, sir. I request Kalyan to introduce about the topic.
Ma'am, so just a second, Kalyan sir. We request all the dignitaries on the virtual platform to kindly turn on their cameras for the group photo.
So, Priyanka, you have to remove this screen before taking.
Yes, ma'am. Kansada ma'am, can you please stop presentation?
Good morning, everyone.
Priyanka, sir, please switch on your video, sir, once.
It's already on, ma'am. Yes.
Okay, Kalyan, can you start?
Okay, ma'am. Good morning, everyone. Myself, I am Dr. Kalyan Srinivas from EC Department, VNRVJIET. My specialization is radio frequency and microengineering, followed by satellite communications. So today, I would like to introduce about this chapter. The IEEE Micro Theory and Technique Society is an organization within the framework of IEEE of members with the principal professional interests in the field of micro theory and techniques. All members of the IEEE are eligible for the membership in the society. The society is managed by an administrative committee, ADCOM, consisting of 21 elected members of the society plus additional ex officio members as provided in the MTTS constitution and bylaws. And this MTTS started in 1952. So we are celebrating our 70th year. So exactly, the society started as a professional group approved on March 7th, 1952 by the Professional Groups Committee of the Institute of Radio Engineers. Ben Warrior IV, a microengineer with General Precision Laboratories in New York, submitted a letter and petition from members of the IRE interested in forming a professional group for microelectronics, and the petition stated that the scope of the group would encompass micro theory, micro circuitry and techniques, micro measurements and micro tubes. So the Micro Theory and Technique Society consists of many active local chapters which sponsor technical meetings, workshops, social events, seminar series, host the annual international micro symposiums, radio and wireless week, and serve the professional and technical needs of members. And thank you so much for the opportunity to serve the MTTS. I consider it an honor and recognize that this task is extremely important. I value ideas and sessions for improving our society. Now, I'm handovering this session to our moderator, D. Kansudha Madam.
Yeah. Thank you, Kalyan. Thank you for that opening note from Priyanka, Padmasai ma'am and Kalyan on this occasion of inauguration of the MTT chapter. So first of all, I would like to invite all the dignitaries who have agreed and consented to us at the last hour to be a part of this panel discussion, which is a very current and apt for us, especially in the context of MTT. So the topic we had chosen was clearing the air on 5G interference on aviation safety and impediments in 5G implementation. So before I go to the panel discussion, I would like to introduce our guest for today who will be part of this panel discussion. So first of all, I would like to invite Mr. Sandeep Chaturvedi, Deputy General Manager, Head MMIC Design Center, Gallium Arsenide Enabling Technology Center. He has readily consented and he was instrumental for us for establishing this chapter also. So coming to his profile, he has done his PhD in microwave engineering from IIT Delhi, and he has done his MSc Electronics from Dr. Hari Singh Gaur University Sagar, MP, and he is also holding a degree in BSc Electronics. So his job profile includes RF characterization of high frequency active and passive devices and MMICs, measurement automation, MMIC packaging and modeling, design of state-of-the-art MMICs. So he has published more than 15 research papers in international journals and conferences. So his research interests include device modeling, packaging, and MMIC design. So he's also a recipient of Gaur Samman in 1997 for securing the first rank in the Faculty of Engineering Sciences in Dr. Hari Singh Gaur University. So it's indeed a great privilege to have you today on this session, sir. I welcome Sandeep, sir.
Thank you, madam. Thank you, Dr. Kanti.
Yes. Next, we have in this panel, we have Subhash Mandal, who is Head of Research and Development, 5G Products at HFCL Limited. He's also IEEE SA Board of Governors Members at Large and Chair-elect IEEE Communication Society, Bangalore. Coming to his education, he has done his BTech in Electronics and Electrical Communication from IIT Kharagpur. His job profile includes the leads, the R&D efforts for 5G product development at HFCL. So he's the chief architect of Wipro's organization-wide 5G initiative from 2018 to 21. He's responsible for driving the standards, contribution, academic collaboration, innovation, partnership with technology partners, open source contribution, and solution building in 5G. He's a passionate technologist and has developed a variety of solutions and frameworks in emerging technology areas such as 5G, SDN, NFV, Li-Fi, cybersecurity, and AI for network automation. He's also recognized as Wipro Fellow for his technical contributions, and he has more than 30 years of engineering experience in telecom research and development. I welcome you, sir. Thank you for being part of this panel discussion.
Thank you, ma'am. Thank you for inviting me.
In this panel discussion, next we have Nishant Tiwari, who is the solution architect for ORAN product development and domain consultant for radio intelligent controller. He has done his BTech in Electronics and Communication Engineering from Uttar Pradesh Technical University. His focus is majorly on 5G and ORAN, radio intelligent controller. He worked with wireless equipment providers such as Ericsson, Nokia, Huawei, Motorola, Cisco, and Intel. He has also worked with all the major global network operators such as AT&T, Sprint, Vodafone, Germany, DTAC, Thailand, TrueMove, Thailand, as well as all the major Indian operators. He is recognized as a member of SGOs like ORAN Alliance and Telecom Infra Project. Welcome, sir. It's a great privilege to have you here on this panel discussion.
Thank you, ma'am. Thank you so much.
So next we have in this panel, Mrs. Archana Bange, who is the Senior Assistant Professor from our EC department. She is also a member of IEEE and a member of CPAD, which is Center for Presencing and Design Thinking. So her education profile includes MTech in Communication Systems from Gulbarga and BTech also from Electronics and Communication Engineering. She has recently submitted her thesis in thesis in Video Quality Prediction in Wireless Networks, JNTU Hyderabad. She also holds a PG Diploma in Innovation and Design Thinking from MIT Emeritus Sloan School. Her chief contribution involves the book titled The Post-Lockdown Restart Manual Framework for Prevention and Mitigation of COVID-19. She has more than 15 years of teaching experience. She has conducted various workshops, FDPs in the area of signal processing and wireless communications, has also been a resource person in ATL and other FDP programs. She has been instrumental in implementing the FM-based streetlight control system for VNRVJIET campus. And she has conducted the first of its kind 36 hours hackathon on IoT in association with Idea Labs. Welcome you, Archana.
Thank you, ma'am. Thank you.
Yeah. So let us go ahead with the panel discussion, which is of interest to all of us. So first, with a beginning note, I would like to say that though all the technologists are very enthusiastic about 5G, so the airlines are quite unhappy with the 5G. So this is the perception which we get to know through all the news articles or whatever we hear about 5G. So I would like to first put a question to Sandeep sir. Sir, airlines warn of chaos if 5G is deployed. So this is the headlines which comes in the news also. So why has the rollout of 5G been a point of contention, especially with respect to the aviation safety? So can I hear from you, sir?
Thank you, Dr. Kanti Sudha. And actually, before I answer this question, I would like to congratulate VNRVJIT for inaugurating the MTTS chapter, which we are formally inaugurating today, but we got it sanctioned a couple of months back. And it was very heartening, to see the, response from VNR to our call, because, we were trying to make a change in scenario where everybody is rushing towards IT sector, software sector. We wanted people to come back to look into hardware aspects also, especially in the RF domain. We have seen, like, if I recall the journey of last 12 months since I took over as chair, we have converted direction of students, turning to these fields which were, kind of considered difficult and taboo. They were not looking forward to study RF subjects. They're just, clearing their papers was probably the topmost priority, and then the rest of the time was, spent rushing towards, learning coding, and then unnecessary competing with those who are actually in the domain of, software and coding. So leaving your own domain. So that was, very pleasant thing for me. And actually, I was fortunate to be associated with a lot of people in this domain after I took over this volunteering, initiative last year. And Subhash is one of them. I think I contacted him sometime mid of last year when VNR was organizing the FDP, and he was, they asked me to scout for some speakers to speak in 5G area. I would like to congratulate the entire team of officials and volunteers of IEEE in general and MTTS student chapter at VNR. And I would like to thank the VNR management for supporting this initiative there. I'm sure that this initiative will go a long way to bring up good quality students and the researchers in the faculty who would contribute deeply to this field. So with that, I would come back to your question, ma'am. Why 5G has made people unhappy? It's probably because of some unthoughtful results that were published in the last minute when 5G was being rolled out. Actually, no physical incident took place, as most of us are aware. But the RTCA, Radio Technical Committee for Astronomers, so they published a 200-page report when these services were about to be rolled out in USA. And they said that, for 5G, one of the allocated bands is 3.3 through 3.8 gigahertz, which is very close to one of the critical instruments in the aircrafts, which is called a radio altimeter. And this is one of the systems which assists the aircrafts in takeoff and landing, especially when you have low visibility. Because otherwise the pilot can take its own call, but when the visibility is low and the terrain is not very friendly, you have rough terrain. These instruments through the techniques of Doppler, FMCW Doppler techniques, they assist the autopilot decision making in takeoff and landing situations. So now this report, which was published a few months back, it said that the altimeters will be disturbed, or they will, you will receive a lot of interference from the ensuing 3. I think in US they said up to 3.98 they wanted to go, and that particular frequency bands, whatever radiations are coming from there, they will disturb the operations of the altimeters, and there is a possibility of false alarms or missing the height judgment in the landing process. So this created, and when you operate the aircraft, it is not simple machine. It's loaded of life. So you have anywhere from 2 to 200, 300 people on board this flying machine. So the moment it comes to decision between life and anything else, you have to put priority. Nobody wants to take responsibility that lives are lost because of them or him, right? So everybody got in panic that if the radiometer operation is disturbed, I think my other fellow panelists will explain why that would happen. So if this gets disturbed, and if there is, like, we call it 6 sigma, if even if this altimeter has this operation 5G operation, and the altimeter operation is 6 sigma also, so 1 in 1 million times also, if you fail, you lose the aircraft and you lose 300 lives or 500 lives or 100 lives, and that is not acceptable, and that created a panic. What ensued in last 2 months, and this, I think this happened in mid of December, when the rollout was declared, and in the following 2 months, the concerned authorization agencies, they took up the job of certifying the altimeters, whether they will work or not work if 5G is made operational. So there were few preventive steps taken and few certifications that took place with the various aircraft manufacturing agencies like Boeing, Airbus, etc. So the preventive steps were that initially, okay, so the telecom operator said that, okay, we will not operate the towers anywhere between half a kilometer radius of the aircraft. So that will at least prevent the interference happening, even if it is pertinent. Okay, so that was one preventive thing, preventive step took. And from the certifying agency side, they have been testing. I was just reading one of the reports. These agencies have tested more than 70, 80 different types of altimeters and have cleared them. So 78, I think, to be exact, so far, and that is continuing. Probably, in my opinion, this should have been done much earlier, before taking a final decision to roll out 5G. So this missed timing and miscommunication, because as a non-specialist, if it is very easy to frighten me. Somebody says 5G will do this, and I have no basis to not believe that. No, you have a lot of such misconceptions about 5G in other domains as well. So in my opinion, that is what made everybody unhappy who is looking for a big business in 5G. And there is another big industry. Civil aviation industry is one of the probably biggest industry with a lot of money and other things involved. So anything disturbing their operation will obviously cut their sleeps and make them. So in my opinion, that is what happened.
Okay, sir. Thank you. Sir, the next question will be to Subhas, sir. Sir, in the recent news also, we have seen that many flights were cancelled to US, and they were not ready to even start the flight, and like that, many losses they had to bear. Is this context only relevant to US, or is it something to do with India also? So your comments on that, sir.
Yeah, so before I can answer that, I will have to set little background. But even before that, I would like to congratulate on starting the MTTS chapter and wishing you all the very best.
Thank you, sir.
And looking forward to a thriving ecosystem in India in the effort to create technology in India. So really appreciate you taking the initiative, ma'am. Now, coming to your question of the aviation safety in US, India, Europe, anywhere in the world, it is pervasive. We need safety everywhere. Like Dr. Rao sir said, safety cannot be an accidental feature, it has to be mandatory feature. Now, having said that, I think Sandeep has cleared a lot of air about the misconception, and I would say that monging to an extent. But let us come to the reality and the technical fact check. India's spectrum auction is going to happen between 3300 and 3670. In US, the C-band spectrum happened from 3700 to 3980. This has been auctioned. The carriers are building the network. And then, like Sandeep said, the RTC 231-page report has assumed an worst case scenario, both due to the radiation coming from the UV as well as radiation coming from the cell towers. And the worst case analysis, I think, is really worst. I do not think it can ever happen. And I'm not going into the technical specifics, but few snippet I will talk, because it is very hard to talk. It is very easy to do whiteboarding and then explain what really is happening. So if you really look into the radar altimeter that Dr. Sandeep talked about, radar altimeters operate in 200 megahertz spectrum band between 4200 and 4400. Now, these aircrafts, this has come probably close to 100 years back. These radar altimeters have started. There has been a regulatory body to certify the radar altimeter. And if you really look into the way it operates, Dr. Sandeep already explained, you send a radio wave, get the reflection back from the obstruction and get back to it. And then that signals are not very strong, right? Now the issue is, when I get the reflected signal back, if there is any interference in that zone, you actually will be drowning that received signal, and therefore you will get into a problem. So the fundamental question that is arising is, if a 5G network radiating between 3700 to 3980 in the US, is it leaking into 4200 to 4400 megahertz band in such a fashion that it is drowning the received signal that is expected to arrive at the measuring instrument into the aviation altimeter? Then the question, if you ask one more probing question beyond that, first question is, why would this, let's say, up to 3980, that is causing the trouble, why would that signal leak into 4200 to 4400 band, right? So if you really look into the 5G has given a clear definition of what is called adjacent channel leakage ratio. The ACLR has to be less than 45 dB of the desired band signal. So if I am operating, let's say, up to 3700, let's say 3670 is where the India will cut off, let's say 3700. If I cut off at 3700, at 3800 megahertz, the signal should get attenuated by 45 dB, right? That is essentially what would happen. Now let us get into a little bit of regulatory framework in US as well as in India. In US, the urban cities where the airports probably would be, well, not necessarily, it could be in the semi-urban areas as well. The maximum allowed radiation power as per FCC is 62 dBm per megahertz. And in the rural area, it is 65 dBm per megahertz. In India, for LTE, I do not know what it will be for 5G. I understand it is going to be more stringent in 5G. So in 4G, it was 53 dBm per megahertz. So if you get into the maths of it, 66 dBm is the maximum allowed power for LTE. For 10 megahertz or 20 megahertz one, it will boil down to 53. If the power is radiated over 20 megahertz, it will go to 55 megahertz if you radiate over 10 megahertz, that maximum power. So considering 53 dBm of radiation power from the base station, and the UVs will be getting maximum radiation power it can permit as per the 3GPP limit is average 23 dBm. And even if you're going for 5G high limit enhancement, the average will still remain at 23 dBm. Now, the question is that the radiation coming from the base station with the 53 dBm per megahertz and the aircraft landing, let us say that the towers are built within 1 kilometer of the airport area. What is the probability that the leakage power going into an upward direction, which typically is not the case, you will always down tilt to make sure that you have the ground coverage. We still do not have a deployment where the drone connectivity in the non-terrestrial region has to be supported, right? That still is not in the purview. It is under research for the upcoming beyond 5G technologies. So the question is, what is the probability of doing that? Yes, there is an argument. It can reflect into some reflecting surfaces and it can still go and interfere. Now, if you assume that 100 meter has been the traverse distance before it goes and hits the altimeter, even if you do the maths, you will realize you still have the safety margin. And you may have seen that FCC has already given some ruling after all this happened. Then Verizon and AT&T, they are actually going ahead with the deployment, but they are being cautious that we'll keep some distance from the airport. Now, coming to India, this problem is much more unlikely, even if you go with the pessimistic analysis that came from RTCA. That analysis says that the power can leak all the way till 3700 megahertz. And because of the poor filtering technique that has been used in the altimeter, even if the adjacent channel is construed to be in-band signal in 42 to 4400, drowning the received signal, even under that condition, the attenuation that will take place, the leakage power will be so low that it is not going to have any implication, at least for India, because we are cutting off 3670. We are not going to 3980, right? Even in Europe, they have been very cautious. They have not gone that far. But having said that, unless you modernize this altimeter, it's a sheer wastage of the bandwidth. Think about it. 200 megahertz on either side, you are saying vacate 600 megahertz, on the other side vacate 600 megahertz. And at the prime frequency band. I think it is a prudent thing to modernize the altimeter and then say that, okay, now the safety has been taken care in the aviation, which is 6 sigma also, like Dr. Sandeep said, is so fatal. We better upgrade the altimeter. Why are we really penalizing the prime spectrum that could have been put to good use, right? So with that, I will pause. I don't think for India there is anything to worry because of our lower regulatory power. We operate at a much more lower power compared to US, number one. Number two, we are operating at a frequency much far away from the 4200 to 4400. So we do not really have to worry about it.
Okay, sir. Thank you, sir. Thank you
I'll
for
just complement this in one sentence. Actually, India has taken that probably more safer approach, and that was not very easy, because earlier we had the 3500 megahertz band dedicated for military radars, and there have been deliberations for last 3 to 4 years, because this was impending proposal to have the 3700 megahertz to 39 megahertz band for 5G. Maybe somebody has realized, or I'm not sure what exactly. So there was a request made to vacate or shift the military radar band to now that's going to be 2933 in the new configuration, so that this band became available. So probably that would help save us. Of course, the point that Subhas brought out, that we cannot waste the bandwidth. It's just time. So our instrument design should improve, and I hope that this message goes out to the manufacturers of such equipments, and we come up with more. Of course, doing filtering like 100 megahertz 45 dB rejection is one of the very difficult things to achieve as hardware engineers, we know. But then when it comes to decisions like this, which impact your economy, which impact the lives there, we have to work out a solution of that.
Thank you, Subha sir. Thank you for throwing light on the technicalities of related to this 5G and why India can be assured that we are not in that danger zone and we are quite safe. Since because US already has given certain instructions like airports and all to have some buffer zones before deployment and before it clears all these safety issues. So I think India is on the go. So coming to that point, Nishant sir, so recently in the budget also we have seen that there was a fund allocation of 5% USO fund allocated for the smooth rollout and especially R&D in 5G. So how do you think the Indian government is ensuring that this 5G rollout will be smooth and without any kind of controversies? Your comment on
So
that.
thank you, ma'am, for this panel discussion. So firstly, I want to say that call drop is a less serious than a airplane drop. So, so I don't think in India that is going to happen because like in if you see Wi-Fi 6, so Wi-Fi 6 having both in 6 gigahertz of the band, we have a both technology Wi-Fi 6 as well as a 5G. So for the indoor, we are going to use a Wi-Fi 6, and for a outdoor, we are going to use a 5G technology. So Indian government has not given 6 gigahertz as a non-licensed band. It's the licensed band. So I think now Indian government have to decide whole 5G band. So if we can see 3GPP standard, so in a 3GPP standard, we have a two band means two frequency range. One is the FR1 and second one is the FR2. So FR1 will come from 420 megahertz to 7.1 gigahertz, and then FR2 band will come around 24 gigahertz to 52 gigahertz. So we will talking about this FR1 band. So initial FR1 band like from 450 megahertz to we can say 2.5 gigahertz. Right now we are using for the 2G, 3G and 4G. And so all these band already using by 2G, 3G and 4G, and a few band like in 1200 megahertz we are using for the TV, like for the TV channel satellite. And then that, and for the 5G we have the band like CBRS band, and then in a C band we have a three band, N77, N78 and N79. And what US is using, that is using a N77. So in C band N77, that is the range from 33 3.3 gigahertz to a 3.9 gigahertz. So why, right, all this aviation related things is come because it is very near to the 4.2, and which is allocated to this aviation safety.
Yes.
But in India, that is going to happen means Reliance Jio experimented in a this N78 band, means they have done their trial in N78, and as well as a European using N78 and N79, and only in US they have allocated N77 band for AT&T and Verizon. So that's why all those things come. But if regular means what's problem happen in US, this FCC and their aviation safety, they have not coordinated well. And otherwise if means if we will go with the advanced technology also, right now we can operate both LTE band in GSM as well as in 4G, so without detecting the interference label. But I don't think how US has done, means their regulatory both FCC and this aviation or Department of Space in the US. But I don't think in India it is going to happen. And before allocating the ban or auctioning the ban, Indian government should coordinate with all these agencies. Like if you going for the millimeter wave, so up to 52 gigahertz, as per the FR2 band, FR2 band is going to start from a 24 gigahertz to 52 gigahertz. But right now, all these band in some part of this band already with the defense or with the satellite, and already satellite is want for their experimental, they want to a band from the 60 gigahertz to the 71 gigahertz. So I think government is going to consider and going to coordinate with all these agency, and after that they are going to allocate the band for the auction. And
Yes.
as per my point of view, government have to do like in 6 gigahertz, they have to allocate both for the Wi-Fi, for indoor coverage, Wi-Fi 6, and for 6G. Because in India, if you see, in 1 megahertz of the band is highly utilized if you see across the globe, and the price of means user what user is giving to the operator is also very less if we compare to US or any country across the globe. So I think in India it is not going to happen, or we are not going to come in any controversy, because we are going to launch a 5G in a delay. We are going to get a 5G services in mid of 2023. So all those things, if technology will come right between how both agency like aviation as well as a 5G, they can coordinate. Because right now we have a different band also, right? And 78, 79. So all these band can interfere with each other, right? But we have a mechanism like how can we can detect the interference, how we can lower down the power, then we can get the signal from the aviation sector. So all this area, both the agency need to coordinate and develop the solution. It's not a hardware solution. They can develop a software solution also, right? Radio intelligent controller type of solution they can develop, and when we can get the signal or aviation sector detect the interference, they can communicate to this 5G, and we can reduce the power also. But right now what is happening, all this, because if you see the AT&T and Verizon, they have paid huge money for this spectrum, and the area where they are where airport having, they are lowering down their this power rate, radiated power. So, and they have already paid the money to the government, and then why they are reducing the power, right? So this is the area of concern for the 5G operator.
Yes.
So, but
Yes.
in India, I don't think, like Subhash sir already told us, we are going to radiate in N78 and in N79. So the problem related to aviation and 5G, it is not going to happen related to interference.
Yes, thank you, sir. As you have told, so I think all the mobile service providers are eager for this auction of 5G spectrum also. So coming to that point, on that note, I would like to ask Archana. Archana, what do you think is the advantage which we have with 5G compared to 4G? Because there are a lot of students also who are part of this panel discussion, and they would definitely like to know, so why so much interest on 5G especially?
Yes, good morning. Am I audible?
Yeah, yeah.
Yeah. Respected dignitaries and my dear friends, and I'm really very excited to be on the board for this panel discussion. And I thank my co-panelists Sandeep sir, Subhash sir, and Nishant sir. Yes. So talking about this topic, and thank you for Subhash sir and Nishant sir for clearing the air for India. And really, we all are very excited. And I, being an academician and seeing what kind of excitement is there in the air regarding what can be done, what applications can be thought of, and there is a lot of excitement in the academia there. So if you are talking about what kind of benefits the 5G is going to offer when compared to its precedents, so we have seen that there was a long growth in terms of generations of the cellular standards there. There have been 1G, 2G, 3G, 4G, and now ultimately people are talking about 5G, and already some of the countries have started implementing it, and India is not going to remain back there. But even now, people are also have started talking about 6G on the discussions there. So, but talking about what 5G is going to offer, what we can say is that definitely 4G standards, we were talking more about broadband services there. Okay, so it was providing more of the video transmissions, like high gaming, online gaming kind of applications it was supporting there. So which was not the part for the lower generations, 3G and 2G, we were mostly for the voice communication there. And just 4G overtook, and you can see that now people are able to download and watch movies, everything being on their smartphone, and it is supporting such high-end applications there. Now, what 5G has in the offerings? What is that 5G is having so much, it has paved the passion for so much for the academicians and the industry. Both are working hard in order to give some exciting applications. So usually what the 5G applications or the use of 5G has been like mostly has a clear-cut division there. Okay, so like talking about how we can enhance the broadband application. So we are talking in terms of enhanced broadband services it's offering. Enhanced broadband services it is offering, and we also have a lot of IoT applications are coming on, and it's fine. Yeah, it's fine. So we can see that there were different proprietary protocols and societies or organizations which were having the network connectivity for IoT there. Now that is also the 5G, what it is looking up is that it's supporting the IoT communications there. So other than our regular broadband services support, which is like it's going to be in terms of hundreds of Mbps, gigabits of Mbps, I think in just within a few seconds you will be able to have your entire movie on your laptop or in your any of your smart devices there. So and the most other important category is that with the growth of this IoT, even 5G is promising the IoT connectivity there. So that is one more area where you see the advantage in terms of IoT. So and you also have a lot of applications we are talking about in terms of which are very mission critical or time critical applications there. So in that way, in terms of you call those kind of applications like high reliability is required there, and they want to have very less delay there. So the latency of I think in terms of less than 1 millisecond is the target there. So these applications fall for example, we want to have a remote surgery, that is telemedicine there. So it's not required for the doctor to be present physically there. So he can suggest the surgery being in some other place, and the operation could be carried out in a different place there. For that, definitely you are going to have a super fast connectivity is required, and the latency has to be in terms of orders of less than 1 milliseconds there. And that's being promised by the 5G there. This is one example I can talk about. And then you have your driverless cars, autonomous cars. So that is coming fast, that is growing fast. Even the connectivity for the driverless cars is being a great promise by the 5G there. Then you have your industrial automation there. So, and if I'm talking about again on the IoT term there, smart cities coming in a big way there. Okay. So these are like, I think the best and exciting part about 5G is that it is trying to unify a lot of applications. They were divided, and now I think it's trying to unify most of the application. So that is one good thing we have about 5G.
Yeah. Thank you, Archana. Thank you for telling us about some of the exciting applications, especially with respect to 5G. Now I would like to go back to Sandeep sir. Sandeep sir, in the last conversation, you have discussed about an in-flight instrument called altimeter. So since it is generally, as you have told also, that it is used for height and all. So what is the actual functionality of an altimeter? Because many of them clearly don't know the functionality, and they don't know that it is related to the frequencies which we are talking about with respect to microwaves and all these things. So just in a brief, would you like to explain us what this altimeter is, which has been a talking point, especially with respect to 5G?
Yeah, I mean, thank you for bringing out that question. Altimeter became famous because of this current discussion, of course. And the previous highlight about the altimeter, if you know, many of you must who are interested in the space journey of India, The altimeter was one of the most talked about topics in Chandrayaan 2 landing, right? The lander, operation. So altimeter, to come back to the actual word, altimeter means an instrument to judge the height, altitude. You want to judge the height of any system with respect to a static reference. In this case, it could be the sea level or it could be the ground level as we defined. So and how do we do it? So we go back to very basic principle in physics, where we most of us have studied about Doppler effect. So Doppler effect says that if I radiate any kind of wave, it could be sound wave, it could be light wave, it could be radio wave, it goes and if it hits a target, the reflected waves come back, and by studying the change that happened in the reflected wave, and by studying the time for this wave to come back, by these two, studying these two parameters, we can decide about the distance to the object and nature of the object, whether it's a static object or a moving object. So in this case, we are mainly focusing about distance. The time it takes for the signal to go and hit the static object, in this case it's terrain or ground, and then come back. Now this particular phenomena or this principle is used in many applications. The radio altimeter, to be specific, uses radio waves, and in this case we are talking about the frequencies in the range of 4200 to 4400 megahertz, as Subhash told in his initial comments. So we generate radio waves of sufficient strength, because when they come back, you want them to be detectable, so sufficient strength. And then when it comes back, you analyze those waves by comparison of the outgoing and incoming wave. It generates a beat frequency, and that beat frequency tells you what is the distance. So this altimeter, I think Nishant told us this was invented back in 1920s. So that's almost 100 years back. And this, various applications have been built upon this principle. And for aircrafts, I think this was operationalized or first used in the early 80s or late 70s, I would say, around 75, 76. And why this was used, like when you have difficult terrains, like Hyderabad is one typical example, where you have difficult. The airport is located in a narrow flat zone, and then surrounding that flat zone you have variable terrain. You have valleys and small hillocks kind of thing. So it is very difficult for the pilot to decide on its own when exactly, how the flight glide path should be decided. So the pilot is assisted with this instrument called radio altimeter, which tells the exact height of the plane, and they have operational guidelines at what angle they should be when they are at a particular height. If it's not happening, they are supposed to pull back, right? So to answer very simple again, altimeter is an instrument using, in this case, the radio waves at 4.2 to 4.4 gigahertz, which is used in all critical landing and takeoff operations for the aircrafts.
Yes, thank you. Thank you for telling us about altimeter. And as you said, altimeter has become popular like never before in the context of 5G. So coming to Subhash sir, how do you think the rollout of 5G will be in India? And do you think it will be able to proliferate into the rural and areas with the present existing networks, or will it take more time for us to actually experience 5G?
Yeah, so that's a difficult question. India is going through this moving target phenomenon to roll out the 5G network, and of course the COVID also has added to the that game. But fundamentally, for the 5G rollout to happen, we need to have the spectrum auction. So as you would have read in the news, there has been a shifting target of the auction, primarily because of there are certain interference challenges with Department of Defense, Department of Space. I think I am presuming that that is more or less put behind, and the India is very close to starting the auction. But again, I am not a regulator to comment when exactly that will happen. But I think the recent from the government also certain targets have been set, but by the Independence Day we should have the 5G network pilot available, right? So with that, I think the country is preparing for that. And again, like I mentioned, that to the knowledge available so far, the auction will be between 3300 megahertz and 3670. So that is decided. FR2 also more or less has been finalized. So both FR1 and FR2 auction will happen. How the network deployment will take place in FR2, we still do not have a sure use case, but fixed mobile applications, right? That is one of the scenarios where there has been movement. The telcos are preparing to have fixed wireless access using FR2 frequencies. So yeah, those are the, but the primary deployment is going to be in FR1 in India.
Yes.
So coming back to your second part of the question, or before that, I think as in any commercial technologies, the telcos would be rolling out where money is, because it's a huge amount of money to be invested, and therefore cities are going to be the first target. It is kind of, you can say, hotspot coverage to begin with, and then it will proliferate with the expansion of the network. Definitely rural India will get that. You are aware of the coverage boosting technology that India TSDSI has contributed. Now it is going to be a standard in release 17. So global community with lot of push, lot of discussion and collaboration. 5G-I has become part of 3GPP release 17. So the ecosystem is preparing all the equipment, R&D centers in India, including us in HFCL. We are preparing to support the 5G-I support. In simple terms, what it means is, if the